Hello, seventh graders. We are going to talk about how to solve some equations. And so whenever I say equations, we're thinking of some value that has the same value as another thing. So a simple equation might be something like x plus 4 equals 9. All right, so the x plus 4 has the same value as 9. And then we're trying to solve for what x equals. So whenever we talk about solving an equation, the object or goal of your equation is to figure out what the variable represents. And when I say variable, we mean that letter or symbol that's representing some other value. So to do that, you want to get the variable by itself, alone on one side of the equation. And to do that, you need to use what we call inverse operations, or you could think opposite operations. So we're going to do a couple that focus with addition and subtraction. So the inverse operation of addition is going to be subtraction, and the inverse operation of subtraction will be addition. So we're gonna skip to number 4 here. Okay, so we have -2 is equal to a minus 8. So -2 has the same value as something minus 8. And so what we want to ask ourselves is we want to find our variable and ask ourselves what's happening to the variable right now. So when I look at this equation, I see that I'm subtracting 8 from the variable. So to undo that, we want to add 8. All right, and so then a rule of equations is whatever we do to one side, we need to do to the other side of our equation. Over here, this subtracting 8, or we could think of this as a negative as well, that zeroes out with that positive 8. And so that leaves me with a by itself, which is what I want. So then I'm going to come over here to the left side of my equation, -2 plus 8. I can do that one in my head. If you need to use your calculator, you can do that. -2 plus 8 is going to be positive 6. So then here a would equal positive 6. We're going to look at another example. So again, the goal of our equation is to figure out what that variable represents. So something plus 7 is equal to -11. So I want to ask myself what's happening to my variable. So right now I'm adding 7 to the x, and so I want to undo that. So how do I undo adding 7? I'm going to subtract 7. When I subtract 7 on that side, my 7s will zero out, leaving me with my x by itself. Whatever I do to one side, I want to do to the other. So I'm going to subtract 7 over here. Now, over here, you could view this as -11 minus 7, or you could think of this as -11 and a -7 that you're combining. Either way, we're going to get -18. So on this particular problem, x is going to equal -18, or have the same value as -18. And I can always check this too, because if my original equation was something plus 7 equals -11, I should be able to plug in -18 for x, and -18 plus 7 is going to give me -11, so that checks out. Same thing when we're solving equations that involve multiplication or division. We want to use inverse operations, so we want to ask ourselves what's happening to the variable and how do we undo that. So the inverse operation of multiplication is going to be division, and the inverse operation of division will be multiplication. So we'll look at a couple here as well. So here I have 63 is equal to -3x. So the very first thing you need to do, we want to find that variable. Now this one's a little trickier. We need to remember what this means when we have a number right next to a variable. So when we have a coefficient in front of a variable, this is representing the operation of multiplication. So x is being multiplied by -3, so I want to undo that. So to undo multiplying, I'm going to need to divide. I'll show my division. I write my division as a fraction. If you would prefer to write it with the division symbol, you can. But I like to show it as a fraction because now I see negative 3x divided by negative 3, and I know that negative 3 divided by negative 3 is going to equal 1 whole. So now I know that I have 1x, or just x by itself. And whatever I do to one side, I need to do to the other side. So 63 divided by negative 3 will equal negative 21, which means that my x has to equal negative 21. And again, I should be able to plug my x value in and confirm. So my original equation was 63 is equal to negative 3x. So if I say x is equal to negative 21, negative 3 times negative 21, if I multiply those together, I get positive 63. So it checks out. On this equation here, I'm going to ask myself what's happening to my variable and how do I undo that? So here I have m divided by 14. So this is written as a fraction. Every fraction is a division problem. How do I undo dividing? I multiply. So I'm going to multiply both sides by 14. What's happening over here is if I multiply straight across, 14 times m is 14m. 1 times 14 is 14. And now I can see that 14 divided by 14 is going to equal 1. So I'm left with 1m, or just m. And then on the right-hand side, if I multiply 8 times 14, I'm going to get 112. So now I know that m is equal to 112. We're going to look at one other example here. All right, so negative 6 is equal to 2/5 m. So when my coefficient is a fraction, right now this is m being multiplied by 2/5. So I can divide both sides by 2/5. But when we're dividing by a fraction, what we are really doing is we end up multiplying by the reciprocal. So multiplying by the reciprocal, this is where in 6th grade, your teachers might have said keep, change, flip. But I want you to know what that really is. So the reason that you would do keep, change, flip is because when you divide by a fraction, you actually end up multiplying by what we call the reciprocal. So the reciprocal of 2/5 is that flip-flop of 2/5. So the reciprocal would be 5/2, 5/2. So if I wanted to divide 2/5 m by 2/5, I can really, I'm going to write this kind of tiny here, multiply by 5/2. And so here's what happens when I do that. 5 times 2, if I multiply straight across, gives me 10. 2 times 5 gives me 10. So I have 10/10 m. 10/10 is going to equal 1 whole, so that 1's out, to leave me with 1m, or just m. So now I have m by itself, which is my goal. Whatever I do to one side, I want to do to the other. So if I multiplied this side by 5/2, I want to multiply this side by 5/2. My negative 6, every whole number has a denominator of 1. And so if I multiply across, 5 times negative 6 gives me negative 30. 2 times 1 gives me 2. And negative 30 divided by 2 will equal negative 15. So I'm going to end up with m is equal to negative 15.